Good morning, Year 10. So on Friday we looked at distances between 2 points, and that used Pythagoras' theorem and forming a right angled triangle, or using that formula by subtracting the x values, squaring them, subtracting the y values, squaring them, adding together, and then that will give you the hypotenuse distance if you square root it. Today we're going to look at midpoints, so halfway points between 2 points. So 2 points on the Cartesian plane I've drawn here, 4 minus 1 and minus 2, 3. So what's the halfway mark between those two? So you can probably estimate this on the diagram. It's going to be around here maybe. It's halfway between the two, but we need to know exactly what that point is. So if you look at it, from minus 2, 3 to 4, 1, it's going to be half. You could use right angle triangles and find half those distances and then work out where that point would be. It's easier to just take the two. So here's my 2 points, minus 2, 3. That's an x and y coordinate. And 4 minus 1, that's also an x and y coordinate. So if I find halfway between the x coordinates and halfway between the y coordinates separately, then that would be the new point. Because if you think about it, this just in with the x coordinates, halfway between those two x coordinates is going to be around here on 1, just because they're both 3 units from 1. And if you did the same with y, you would get the middle ground, the halfway mark. So if I did call this x1, y1, x2, y2. Okay, so I'm going to find halfway between minus 2 plus 4 and find halfway. And that would give, so minus 2 plus 4 is 2. 2 divided by 2 is 1. Okay, and I do that, so that's the x's done. I'm going to do that for the y's here. 3, take away 1, so that's 3 or minus 1. Divide by 2, find halfway, so 3 take away 1 is 2. It's 1 as well. Okay, so does this work by getting the average between the two, or halfway between the two? And I get 1, 1 as my final answer. Well, let's plot that in the diagram. 1, 1 is here. Does that look like it's halfway? Well, yeah, it's perfectly halfway. If my diagram was more accurate and I'd drawn it with a better ruler, it would be perfectly accurate. So this is how we do it. We just add the x's together, whatever their signs are. So you might need to subtract. Divide it by 2, and then do the same for the y's. So there's a formula for that. x1 plus x2 divided by 2, and the other will be y1 plus y2 divided by 2. So get the x coordinates, half them, put them together, half them, and the same for the y coordinates, and that will give you the midpoint, the halfway point of both. Okay? So that is the midpoint. Now we're going to be moving on to lines. So anytime you join 2 points, you get a line. So for instance, if I would join these 2 points, minus 1, 1, and 4, 2, I would get a line like that. It could go on forever, but let's stop it there. And if I join these 2 points, I also get a line. Okay, so joining 2 points gives me a line, in this case, just a line segment. It could continue off the screen, but I'm just giving you part of this line. Okay, so you can see that these lines are different. If you want to think of it like a mountain climb, which would be easier to climb? Well, going from left to right, this one's going to be easier. It's got a lower gradient or slope. This one has a really difficult slope. It's really going to be really steep if you're thinking of climbing it. And that's what slope is. How difficult it would be to climb, or what gradient of a mountain it would be if it were one. Of course, it's not, it's just a line. So this is not very steep, but how do I say how much not steep it is? Well, I form that right angle triangle that we've been doing before. If I form a right angle triangle here, I get how much it goes up and how much it goes across. So it only goes up 1 unit, but it goes across 5 units. Okay, so maybe I could form a fraction out of that. For every 5 units goes over, it's only going up 1. And that is what slope or gradient, same thing, is. You can write how much it rises, 1, over how much it runs across, 5. So the slope of this line is 1 over 5. Doing the same this one, I expected bigger numbers. So this is just 1/5. The slope of this number was not even at 1. This one, let's do the same thing. Form a right angle triangle. Count my units across. This is 2 boxes across. This is, well, there's a lot going up, 6. Okay, so let's form the slope here. Rise over run. For this one is, well, this one, rise is 6. For every 2 it goes over. And 6 divided by 2 is 3. So this one has a slope of 1/5, not even 1. Pretty close to being flat. 0 would be a flat one here, if you think about it. And this one has a slope of 3. So yeah, it's quite a steep slope. It's a lot steeper than the 1/5 one. Now, going from left to right, that's positive slopes. Both these have a positive slope. If you're going uphill, it's positive. If you're going downhill, it's going to be negative. So for instance, if I have a new point here at 3, 0, and I'm going to find the slope of this new line, this line between here and here, well, I can draw a new right angle triangle. It rises 4. Well, it's actually going down 4 for every 2 it goes over, if you think about it. So this slope of the second line, because it's going down instead of going up, this is a negative slope. It's actually going down 4 for every 2 it runs over. And this is a slope of -2. So that's gradient or slope. Now there is a formula for this as well. You can draw it, or you can use this formula. The slope, which has a letter N, that's the symbol for slope, is the y-coordinates subtracted from each other. So let's look at that. In this particular example, the y-coordinate here was 1, and here is 2. So I've taken away the second y-coordinate, y2. 2 minus 1 give 1. And if I subtract the x-coordinates, I get the difference between those two. In other words, how much is run across. So from 4 back to -1 is a distance of 5. Which gives, let's use this example. I'm going to call this x1, y1, x2, y2. Well, I actually call this one x1. Let's call this the second point. Okay. So y2 from here is the second y-coordinate. That's number 2 minus y1 is 1 here. Okay, x2, which is the second coordinate up here, is 4. X1 is -1. Now there's already a minus here, so it's double minus. It's minus minus 1. It's good practice to put that in brackets. So 2 take away 1 on top does give me the 1. Now 4 minus minus 1 before adding 1, which is actually 5. So that's using this formula. Now you see this formula and some more examples of it in the book. So I'm going to set you some questions from the book on both gradient and midpoint. So remember, midpoint is the halfway mark between 2 points. Add the x coordinates together, divide by 2, add the y coordinates together separately, and divide by 2, and that'll give you a new point. That's midpoint. For slope, you're looking at how steep the line is. So you need to either use this formula or just draw a right angle triangle and count the boxes. And it's rise, how much it goes up, by how much it runs over. Now that will be different, of course, if you're going downhill. That's how much it goes down by how much it runs over. And that's for both a positive and negative slope. Remember, negative slope is if you're going downhill, and positive slope is going if you're uphill. Okay? So I'm going to set you some questions on this. I'll be available on Google Hangouts. If you have any further questions, do let me know, and I'll be checking your work on distances. Okay, good luck.